Guys, composite functions. A composite function, a function composition is applying one function to the result of another. Basically, we'll be subbing one function into another. Another way of saying this is a composite function can be thought of as a combination of two functions. We're combining two functions. The composites of two functions, f of x and g of x, there's two possibilities. We could sub the f of x into the g of x, which would be that first option, which is g of f of x, or we could sub the g of x into the f of x. So it's f of g of x. Told you it was a bit wordy. For a real number a to be in the domain of g of x, a must be in the domain of f of x, and then f of a must be in the domain of g of x, because we're going to be trying to find the domain and range of these composite functions. I think I might just skip the wordy part. It's much easier when I do it.
Yeah.
Let's go to the examples. Okay, first one, we're just going to be practicing finding our composite functions. For the first one, we want to find g of f of x, which means we take the f of x, this is what f of x is equal to, and that is going to replace the x everywhere. There's only one for this one, but everywhere where there's an x, you would put that into the g of x function. Okay, so g of f of x is putting the x plus 2 where the x is in the other function, which would need to be squared because it's x squared. The other function is x squared, right? Now, we could expand that out.
So what? Oh, wait, yeah, no mind.
Because x squared plus 4x plus 4. Now, it is important which one you sub into which, because now we're going to do the other direction. I'm now going to sub the g of x, because that's the middle part. I'm going to sub that into the f of x function where the x is. So that means f of g of x, I'm subbing the g of x function in, which would be x squared where the x is, plus a 2. And I can't simplify that, so that's it. Okay, so just subbing one function into the other. The one that's on the inside, the function on the inside is the one you're subbing into the other one, the outside one. Let's try that again. Question 2. I have my two functions here at the top of the page, f of x and g of x. And the first thing I want to find is g of f of x. So I want to take the f of x, that's the inside function, and I want to put that into the g of x where the x is. So g of f of x equals 1 minus 2, but instead of x, my x is now the 3x plus 5. And I expand that out, would be 1 minus 6x times in that, and then minus 2 times 5 makes minus 10. Collecting up like terms, I have minus 6x. 1 take away 10 is negative 9. Let's do the other way. I'm wanting to find f of g of x. So the g of x is on the inside. And I'm wanting to sub that in to the x in the f of x function. So f of g of x is equal to 3. Instead of x, it's the g of x function, 1 minus 2x plus 5. Getting the idea?
Yeah.
It's a little bit weird, I know, at first, but it's just subbing one thing into the other, kind of like simultaneous equations with some weird notation in there. So expand out the brackets. 3 times 1 is 3, minus 3 times 2 is 6x plus 5. Collecting like terms, that's 8 minus 6x. Now, that was a bit of practice. Question 3, we have an f of x function and we have a g of x function, and we want to find the domain and range of the g of f of x function. Okay, the easiest way to do this, there is a couple of strategies. If you read through the examples in your textbook, they use a slightly different strategy perhaps, but I think this is the easiest way to do it. Like we've just been doing, we want to sub the f of x function into the g of x function. So f of x is equal to this. I want to put that in there where the x is to start with. So that is g of f of x is going to be equal to 1 over, and instead of the x, we put our function in there, square root of x minus 1. Now we have the equation of this new composite function, and we want to find the domain and range of it. Now, some of them will be familiar types of graphs, some of them not so much. Domain, however, is usually the easiest to find. We're looking for what are the possible x values that could have. Now, the fraction tells us the denominator can't be 0, so we know that x cannot be equal to 1 because that would make the whole surd 0. We also know because there's a surd there that denominator can't be negative because we can't square root something and get a negative answer. All right? That's right. So my domain, not equal to, oh, you said 2. No. My x is greater than, but not equal to 1.
Is that the same as x is greater or equal to 2?
No, because it could be 1.1 or 1.000001. It only has to be microscopically larger than 1 and it will work. Okay? The range. Now, because we don't really know what that graph looks like, the easiest way to determine the range is to draw a little table just with a few values in it. I'm going to sub in a few x values. I'm just going to call it the y on the bottom because I don't want to write g of f of x again. But I'm going to be subbing it into that function. Now, my x values have to be larger than 1. If there was an equal to sign on that, I would choose my first value to be 1 because you want to start with the very first x value that you can have. However, I want to pick a very close number to that. So I'm going to pick 1.00, let's even go 0.1. There we go, something really, really close to 1, but just slightly bigger than it. Then I'm going to skip a few things. Let's go to 10 after that. And then I want to pick something big because I know x can be up to infinity if I wanted it to be. But I want to just try a really, no, bigger, come on. I'm going to actually choose, now I have some strategy in here. I'm choosing 101 because I know I have to subtract 1 off it. And that makes a number that's nice to square root. Okay, but you can choose any number, okay? It doesn't matter if it goes to a decimal here. But I've just chosen a nice one here. So, to find the y values, Annabelle, calm down. Use your calculator, sub in 1 over, here you go, I'll bring mine up, 1 over square root of 1.0001 minus 1. And that gives me 100. Because that was the formula. That was my orange rule here. If I had put even more zeros in there, the more zeros I put in that 1.000, the bigger that number is going to become. Does that make sense? Because it makes that denominator super, super small, and 1 divided by a super small number makes a really, really big number. All right, let's try 10. Go back through here. You don't have to rewrite it. You just can delete and change that to a 10, which is a third. And then let's have a look at our big number, which was 101. And that's 1/10. So you can see, even though I've jumped up from 10 to 101, I've gone from a third to 1/10. Those numbers, the bigger the value I put in there, the smaller that y value is going to get. Is it ever going to get to 0?
No.
No, because we know that denominator is never actually going to be able to get to 0. So that's not going to happen. So having a look at those y values there, we know that y can get really, really big. And we know that it has to be bigger than 0. and it can't be equal to 0. So we get our range as y is greater than 0. Now, that is how I would suggest you do it. You may see this kind of notation, and it's not going to hurt for you to witness this, even if you don't choose to do this method. Because x is equal to x was greater than 1 was my domain, I want to see what is happening as x is getting bigger, or is approaching that 1. So I say as x is approaching 1, I want to know what is happening to my y value. When I sub 1 into here, this is what we were talking about before, 1 minus 1 is getting close to 0, or a really small number, and 1 divided by a really small number is a really big number, which means that y is going to be approaching infinity. And we even put on the end of that a little plus sign, which says it's did I go the right way? As y is approaching 1? Yes, it is approaching infinity. Then, as the x is approaching infinity, if x is getting really, really big now, then that means that my denominator is going to be getting bigger and bigger and bigger. It doesn't matter that you're square rooting a really big number, it's still going to be a big number. And 1 divided by a big number is going to be getting really small. But it does still stay positive, so it's getting close to 0, but that little plus on the end means that it's still going to stay positive. So it's approaching 0 on the positive side. Or the first one was getting close to infinity, but positive infinity. Okay? So doing it that way as well, you could also see that looking at those y values, that y is going to be starting close to 0 and just getting larger from there. So you also get the range of y, not with the highlighter, y is greater than 0. Okay? That question there, let me just stop my video because I don't